Hello, business school students. My name is James, and welcome to the Business Analytics Peer Learning video tutorial series. In this tutorial, I will walk you through a typical hypothesis testing question, including how to set out your data, hypotheses, and test equation. Hopefully, this tutorial will be helpful to your final exam preparations.
Here's our example question. You may pause this video to note down any data that you think might be relevant and to compare notes. So upon reading this question, we know that we are asking to compare two different job designs, difference in the productivity of these two job designs, and we can highlight that the sample size of design A is 20, and similarly for design B is also 20. For illustration purposes, I have set out the sample mean and the sample variance in actual number form, whereas an exam question is more like to have these within the text of the question. So you need to read the question thoroughly in order to find out what are the data. Because the first step in any hypothesis testing question is to state your data. And here we have sample mean of our design A equals to 6.288. The sample standard deviation for our design A is 0.92, and the sample size similarly is 20, as we can find out from the question here. We also need to set out our design 2, so we'll denote that with x bar 2. That is 6.016. Our sample standard deviation for our design 2, 0.14, and our sample mean for design 2 is also 20. The second step would be to state our hypothesis, and in this step we'll need to refer back to a question. Here we ask to investigate whether the job designs affect the workers' productivity. So what our H0 would be that whether the population mean for our design A equals to the population mean of our design B. Intuitively, this is the hypothesis we're testing, but actually for ease of substitution later on, you can also set your hypothesis as in the form of, and I will show you why this in a second. And to set out our HA, that is our alternative, that there is a difference between the two designs, and in that case this wouldn't be 0. Next, in our third step, we need to set out and state our test statistic and any assumptions that we're making. In this question, we're not told the population variance or standard deviation, and we note the sample standard deviation are quite similar, but at the same time we note the sample size are quite small, only 20, whereas for this central limit theorem to apply, we usually need a population sample size of more than 30. Therefore, we need to make a couple assumptions to go with our test statistic. First of all is that we have no information on the population standard deviation or variance, so sigma is unknown. Secondly, we have n equals to 20, so we can't say that CLT apply. If it were more than 30, we could say n equals to so and so, and therefore CLT applies. but this isn't the case here. So we'll clean that up. Equals to 20, and that we consider rather, our judgment is that the sample variants are quite similar. In addition, we must assume normality. And our test statistic from your slide would be of the following. Degree of freedom would be n1 plus n2 minus 2, and our variance would be 1. Now, you do not need to set all of these into the one line. In the final exam, you'll be using exam booklets that have plenty of space for you to set your answers out neatly and legibly for the marker, so make sure you do that. Now, as I've mentioned earlier, when we set out our hypothesis, the reason you write your hypothesis in this way is that you can easily substitute this part into your test statistic quite easily, as you can see here. Now the next step is to state your decision rule, and it's recommended that you draw a diagram, or rather that you always draw a diagram so you don't get confused of what your decision rule might be. So here we actually have to work out our degree of freedom first, very quickly. So -2, and that's 38. Next step is to draw a diagram to show our rejection zone and state our decision rule. I'm just going to scroll the page a bit to give myself a little room. We have from our alternative hypothesis HA that we have a two-tail test, but what might happen is the question might not give you a level of significance, so you need to state your own. You need to choose and state your own level of significance, and here we'll do 0.05. Now the next step, because it's a t statistic and you have degree freedom of 38, the t-table might not have the critical value for the degree of freedom in your question, and in this case 38. What you will do is assume a critical value with a similar degree of freedom, or rather the nearest. So for 38 you might go with 40, but you might also go with 35. Then note down your critical value on the graph. Make sure you shadow the rejection zone, and if I look up for degree of freedom 40, this would be 2.021, and this would be minus 2.021. We'll do a little more scrolling and write down our decision rule. That is, we reject H0 if the absolute value of our t stats is more than our critical value, and in this case it's 2.021. Let me just move this, and otherwise do not reject H0. Now we can proceed with actually calculating our test statistic. We'll start with our pooled sample variance here. So it's this part equals to 19 times 0.92. It's 19 times 1.14 squared by 38. And the total is 1.073. Trust me on this. You can also check my work if you like. And if we substitute this number back into here, we have 6.288 minus 6.016 as we have set out in step 1, minus 0, which is this part here, over square root 1.073, 1 over 20 plus 1 over 20, and this equals to 0.272 over and equals to. Okay, so we've worked out our test statistic equals to, at the end, 0.83, and we have earlier our decision rule here. The next step would be to write out our decision based on our decision rule earlier, and I'll just scroll to give myself a little more space. And the decision is since our t star is 0.83, which is less than our critical value 21 equals to t 0.25 40, do not reject H0 at a significance of alpha equals to 0.05. Finally, we need to conclude our findings in words. So let's zoom out the page again just to have a look at what the original question is asking. So it's asking whether the job design affect the worker's productivity. And for our conclusion, that the conclusion is that there is insufficient evidence to conclude job design A and B has different worker productivity at the 5% significance level, or however you would like to phrase that statement, as long as you state it in plain and simple word. So just to summarize your test statistic at the very end. Just to recap, we have, I'll use a different color. So we have step 1, state our data. Step 2, state our hypothesis. Step 3 is to state our test statistics and any assumptions. Step 4 would be to draw your rejection region and state your rejection rule. That's here. And step 5 would be the actual calculation. That's including this part as well. So these are step 5. Step 6 would be your decision based on your decision rule. And finally, step 7 is the conclusion. Hopefully you find this video helpful in terms of the scope of proper working in an exam question. Thank you for your attention, and we'll see you in the next video.